So in this lesson, we're dealing with objects that have forces in two dimensions. And I'll just back up briefly here. So if I'm looking at these free body diagrams here, this would be one dimension. Like up and down would be one dimension. Here, this is also one dimension. But like number three has up and down, but it also has side to side, or in other words, vertical and horizontal. So we're looking at objects like that today. And we'll just jump right into the problem. It says Chuck Nolan pushes a 5 kilogram FedEx box on a frictionless surface to the right with a 2.5 Newton force. And so for part A, we'll draw a free body diagram. The box has a gravitational force mg. It has a normal force Fn because the surface is pushing back up against the box. And Chuck Nolan is pushing to the right with a force. Now we could call this Fp as we've done before, but I realized on the assignment we called it F1. And so we'll just do that. It's just a name. Cool, and that's the free body diagram. For part B, well, let's do it this way. So how do we deal with this given that we have one dimension here and two dimensions here? Because Newton's second law, which we'll write down, only works one-dimensionally. So this equation can work vertically or it can work horizontally. And so really what we're going to do is we're going to do two of them. Let's do a vertical equation and let's do a horizontal equation. And before we get going, we want to realize which way is the box accelerating. So we'll think about this. Like we have a table and we have a box and we're pushing it to the right. Well, it's going to accelerate to the right. So next to the free body diagram, I'm going to write it's got a rightward acceleration. Okay. So let's go to the equation, F equals ma. Let's look at the vertical. And by vertical, I mean we're only looking at what's going on vertically. So I only want these forces in that equation. But I'm going to start here and we ask ourselves, is there acceleration, but vertically? Is there vertical acceleration to the box? Which the answer is no, right? Because the box over here, it's not accelerating up or down. And so vertically, it has zero acceleration. And so the mass of the box is 5. 5 times 0 is also 0. And now we need to put in our vertical forces. Since the acceleration is 0, it doesn't matter which one goes first. So I'm going to put Fn, and I'm going to subtract mg because they're in opposite directions. So I'm going to leave it right there for now. We're going to finish this up later. Horizontally, I look at the free body diagram. There is horizontal acceleration. So we're going to keep that part of the equation. We'll substitute later. And we only want the horizontal force that it has, which in this case is F1. So that's it. That's it for writing them. Now let's solve B and C. B wants to know what is the normal force, but if we go to our equations, Fn is only one of those, it's in this one, so we're going to solve B here. And then C is about the acceleration. So we're going to go and solve this one over here for C, because the acceleration is in this equation. Let's start with B. Let's figure out Fn. We'll isolate Fn, so we'll add mg to both sides. And so we get Fn equals mg. The mass of the box is 5 kilograms. G always has a value of 10. Let's not forget that. G is really close to, we're going to say approximately, but we're going to use 10 newtons per kilogram. But we can do this in our heads. 5 times 10 is 50 newtons of force. For part C, we're going to solve for the acceleration. And so we want to isolate the acceleration. We're going to divide both sides by m, because that'll get rid of it there. We have F1 over m. F1 is the pushing force, which is 2.5 newtons. And the mass is 5. So 2.5 over 5 is 0.5 meters per second squared. There we go. And that's pretty much it for solving these. On a quiz, I would give you a point for the vertical forces, a point for the horizontal force. When I get to the vertical, I'm looking for 0 acceleration vertically. I'd give you a point here. Give you a point for substituting your forces, a point for the answer. When I come to the horizontal equation, I'll give you a point for the equation, a point for putting only your F1 force for the sum of forces, answer, and we would give you a point for the units. So that would be about 1, 2, 3, 4, 5, 6, 7, 8. Looks like 9 points for that. Cool. Let's just do the other one. So this time Chuck Nolan is pushing the 12-kilogram FedEx box on a flat sandy beach with a rightward force of 52 newtons. There is a friction force on the box. So let's show what that would look like on the free body diagram. So we'll put gravitational force, mg, we'll put normal force from the beach. We have a rightward, let's call it F1, pushing force, and friction is on the box. Friction will oppose the direction in which it's slipping, so we'll put some friction this way. We'll write Newton's second law. We'll do vertical, and we'll do horizontal. And in a very similar way, we'll do the same thing. Now, vertically, is there any acceleration? And before we do this, let's talk about which way it's accelerating. If we're pushing it to the right, it's going to accelerate to the right. It won't accelerate up or down. And so there's 0 acceleration here. So m times 0 is 0. We'll put our vertical forces. We'll subtract them because they're in opposite directions. And we'll get exactly the same thing we got before, but with these numbers. So the mass is 12, g is 10, and so that's 120 newtons. Horizontally, there is acceleration, so we'll keep ma. But now we'll put our horizontal forces. Now, the force that gets the acceleration going, that force goes first. So that's F1. And we will subtract the friction force because it's going in an opposite direction. But this time we want to calculate for the acceleration. So we'll divide both sides by m to isolate the acceleration. And I'm just going to put in my numbers now. The pushing force F1 is 52. The friction force is 48. And the mass, once again, is 12. So this comes out to 4 over 12 which is 1/3, which is 0.33 meters per second squared. Okay, similar scoring for the points here. I would give you a point for the vertical forces, probably a point here and a point here. Point for 0, a point for your forces, and answer. Equation, substituting your forces, answer, and 1 for all the correct units, which is newtons and meters per second squared. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like 10 points for that one. On your assignment, I think I mostly ask you for the horizontal equation. I think there's only one or so that asks for the vertical equation. Because, as you notice, the vertical equation looks very similar every time we do it, where Fn equals mg. By the way, this doesn't always happen, but in these problems it does. And that's it for forces in 2 dimensions.